Now that I know what the form is called, let me start learning how to perform operations. According to BODMAS, I should start with the powers, but how do I calculate powers of I? You may start thinking, where did this question come from? That was not the next question that I had in mind. For the next few lectures, we will be learning how to perform operations with complex numbers. After all, you should know how to deal with addition, subtraction, multiplication, and division for complex numbers. When doing multiplication, we will have to resolve powers of I, so it is best we do that now. The best way to evaluate powers of I is by doing examples. Let us start with the power of I to the 0 and move our way up. I to the power of 0 is 1. I to the power of 1 is I. I to the power of 2 is negative 1. I to the power of 3 is negative I. I to the power of 4 is 1. I to the power of 5 is I. But wait, did I not get these values already? Let me make a prediction. I to the power of 6 is negative 1. Let me see. I to the power of 6 is negative 1. I was correct. It seems to be following a pattern, doesn't it? Yes, it is. And let me generalize this pattern. I to the power of n is equivalent to I to the power of the remainder of n divided by 4. Let me try this with I to the power of 7. I expect to get negative I. I to the power of 7, I to the power of the remainder of 7 divided by 4. The remainder of 7 divided by 4 is 3, so I to the power of 3 is negative I. It worked. Now this is very helpful when you need to mentally compute powers of I, but it is not very math-like. Let me state it like a math person should. Since I'm going in circles, let me use a circle to represent this. For all m and n that belongs to the set of whole numbers, I to the power of m is 1 if m has the form of 4 times n. I to the power of m is I if m has the form 4n plus 1. I to the power of m is negative 1 if m has the form 4n plus 2. And finally, I to the power of m is negative I if m has the form 4n plus 3. And we just complete this by going in circles.